So the image filter library has predefined filters that basically work on the basis of preset coefficients of kernels. So kernels essentially are small square matrices. That's all. Right? So it's a 3 by 3 or a 5 by 5 square matrix. That's it's all to it. So in image processing speak, we say that it's a kernel because this small little matrix is to be multiplied by the 3 by 3 or 5 by 5 cropping of the original image, multiply, 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 and then create the outcome after the multiplication as such. So it is basically a new term that is not giving us any new concept. Okay, so just treat this kernel, a scary name, as a small square matrix. Now we don't really need a very large kernels here. So even though it is limited to 3 by 3, 5 by 5, it's pretty sufficient to do very powerful and imaginative stuff. So what is it used for, a kernel? The kernel is used for us to, is meant for us to create our own matrix coefficients. For example, in all the preset filters that we saw earlier on in image filter library, because they have to support the commonly used filters. Sometimes if we want to, for example, have a filter that enhances the right side of a object or potential object and not the left side, we can specify under this matrix. So it is a 3 by 3 matrix presented to Python as a list, single list of 9 integers. But for ease of understanding, I broke it down into 3 lines, each line having 3 coefficients. So it's 3 by 3, right? So visually we see it's 3 by 3, but Python sees it as 9 integers. So we sent it into image filter dot kernel, which will produce an object kernel that can be used in the dot filter function. So this kernel, again, what is kernel? Nothing scary. It's just a 3 by 3, 5 by 5 matrix. So has a size of 3 comma 3, all right, and then the list of integers to or list of values to support the kernel, and followed by a scale of 1 over 6. Why 1 over 6? Well, this is to magnify or diminish the outcome, the output. And why is it 6? Someone might have noticed, or seems like, you just add up the magnitudes of the values here, right? And answer is yes. So idea is, if you don't want to accidentally brighten the image, because your filter is not to brighten it. If your filter is meant to brighten it, then fine. It will be the total weight will be larger than 1. But if your whole idea is to, like, in this case, enhance the right side, diminish the left side, but don't contribute to more white light, more light energy in the object. I want it to be overall balanced, but shift more energy to the right and diminish to the left, right? So in the case, when you make sure that the weights are added up to 1 exactly, that would be achieving the purpose of not magnifying it nor diminishing the overall light balance. So, and we try to, just like a bit of a shifting of the energy. We move all the ones to the right. We shift. In fact, we don't leave the left hand side untouched, but we diminish it actively. So we put a -1 on the left. So in this case, the outcome becomes, when we apply, or rather when filter efficiently applies the kernel all the way through all the 3 by 3 cropping and subpixels of the original image, this is what we get, where the right side, right edges of any discernible object gets enhanced, and the left side is not left as it is, but diminished. It's darkened until we almost cannot see it. And if you see it, it's more because it was thought of as the right side of another nearby object. Okay, so all the right sides get enhanced, and end up we get this very, very a strange neon light setting that is quite vertical looking. Now, of course, the kernel is just a kernel. The layout of the kernel seems to tally with the effects that we see. But of course, our eyes are a bit, working on its own. What if I want to enhance the left side and diminish the right side? So very simple, right? You get it. So you just change all the -1 to ones and ones to -1s. Let's try another time. What if I want to enhance the top side and diminish the bottom side of, any discernible objects? Then, right, so it's 1, 1, 1, 0, 0, 0, and -1, -1, -1, with an overall scale of 1, 6. This 1, 6, you can think of it as actually should be 1, 6, comma 1, 6, comma 1, 6. 0 times 1, 6 is 0, 0, 0, 0, and -1, 6, -1, 6, -1, 6, so that we add up to in total, zero energy contribution, but it will be far nicer and cleaner to see that, oh yeah, in fact, we can also say 2, 2, 2 and -1 here, to really push up the energy on the top side. And then we can scale down by adding the absolute values of all the coefficients so that overall it is not exceeding 1. Okay, so when we do this on the overall original image, we get this pretty corresponding, not totally surprising image where the top lines of any objects get enhanced and the bottom edges get diminished actively, right? So we see darkened areas as well. And this could be the detection, the beginning filter of a detection of rising sea level automatically, right? So because we want to detect the top side of the wave or something like that, or whatever it is, right? So there can be some use of this. Now, if you are beginning to find that, wow, what's all this kernel matrix and coefficients and what don't exceed 1 and energy stuff, if you start to find it a bit, slightly beyond your taste or your willingness to comprehend, let's put it that way. Very simple. Just ignore all this. You can also take it as neon light, artistic drawing, and you can play around with the coefficients to get to see what is the outcome without knowing or expecting what's the outcome. And some of these combinations can create very bizarre yet unexpectedly pleasant outcomes that may be very artistic, very impressive, and very aesthetically satisfying, but it may not be useful scientifically. That's fine, no problem, right? So do play around with this, and because it's so simple, so straightforward, when earlier on one would have to write a very long-winded C program, include libraries, debug day and night to get all these done. So definitely try to enjoy this really powerful library that is also free of charge. Isn't that wonderful, right? Okay, so see you in the next video where we'll discuss a lot more about creativity, ability to draw and write onto the canvas. See ya.